We are live. Annika, hello.
I'm here.
This is a very special joint venture that we have going. This is the very first ever Invent FM B2B nTop Live. The first of many collaborations to come. So
Definitely. Well,
thanks.
happy to be here and happy to kick it off. Thanks for
Awesome.
having me.
Yeah, so everybody who's just joining us live, this is the one and only Annika Norden. She is my favorite help with making me a successful nTopology customer. She is a customer success engineer and clearly very good at her job, because we're going to talk about how successful we have been today. I'm not sure what the definition of success that you guys use internally for your metrics is, but I would say, delivering high quality additive manufacturing products to Santa's wish list is one definition of success.
Yep, definitely.
Although we want to make sure that this is non-denominational. We're here in the universal church of symmetry and solstice to celebrate. So before we dive into the solstice symmetry of these additive ornaments, and I think it's a fun, we're having fun. It's holidays, it's seasonal, but I think what's really exciting to me about this is, it is goofy, it is kind of simple, but we really were able to, design something in nTop in like minutes and have it be available as a, production print on demand product like days later. And I think that's an important workflow and something that I think is a very important sort of capability that exists now that people should know about. Annika, before I jump into the nTop notebook to kind of reveal the behind the scenes blueprints on these ornaments, is there anything you want to, I don't know, share, or you think we should give people a heads up about?
Yeah, well, I think jumping off what you were saying about how this workflow was a fun one. I work with a lot of customers that are creating really important and cool parts within nTop, but I do think these little fun projects like creating a beautiful ornament are just as exciting. It's a great project to get you into the software and like really show off the power of it as well. And I think this is a very exciting one, so I'm excited to talk about it today.
Awesome. Yes, it is a good way to learn nTopology, and hopefully we'll be able to teach it here a little bit through this. So let me now dive in. And I think in some ways this is like my midterm examination here. I think, I'm about one semester in to my tutelage under the customer success group, including Annika and Chase, who will give a shout out to. So Annika is going to grade me on my midterm here in terms of my nTopology skills, and also we'll just invite. We've got a good number of folks joining us live. If you have any questions, we want to make this interactive. Please do use the Q&A box versus the chat box. That makes it easier for us to handle. And Annika is going to help me sort of figure out the right flow in terms of when we answer those questions. Okay, so we're going to go the trajectory of the presentation today. We're going to go all the way from revealing the blueprint, so to speak, how we design this in a matter of minutes, literally. It probably took me longer to clean up the notebook for the presentation than it did for me to design the ornament in the first place. Talk about what that means in terms of parametric design, reusable workflows. Then we're gonna show, some photos of how we made them in action. We'll reveal them live in person and give you a high-res camera view. So to start things off, I guess one of the things that I learned in nTop is, and one of the reasons that I like it a lot, and I would just want to say, I tell this story a lot, so Annika's like heard this one before, but I'll say, I am a chemist, and even though I run a 3D printing company, I have had a very hard time with CAD throughout my career. It's really not fun for me. I really enjoy programming languages. I really enjoy typing code and writing functions. I don't really enjoy like dragging the corners of boxes around. And so nTop has been super fun for me because, you know, while it is sort of graphical and kind of needs to be by virtue of being CAD, it really has a lot of elements of like a much more like functional kind of programming language, or and it's parametric by design. So what does that mean? So we're going to do a little homework up front, and we're going to set some of the parameters that we care about. So we're going to set the radius of the ornament, the height of the ornament, and the radius of the torus that's going to make our hook. So I've got all these set up as scalar variable inputs, and what is going to be important is by doing that work up front, we're going to be able to scale these however we want going forward. So this is also a short enough workbook that I'm gonna literally open every single block so that people can see behind the scenes. And maybe for some of the pros, these early ones will be a little bit boring, but I promise I've compiled some really great tips and tricks from the nTop team to display here on my midterm examination. So first off, we're gonna start with, just a cylinder. Super easy. This is going to be kind of the bounding box of the ornament that we're trying to create. And obviously it's set by the height and the radius up above. Okay, then to make a hook, all we're going to do is first, I'm going to make this torus. And again, all of this stuff is relative. So actually, I missed one. I could have put this one up front, but almost all of them are defined purely from the top. So where this thing sits in space, it will move relative to all those scalar variables, right? And then we're going to blend them. I guess union them with a blend radius would be the more correct term. So I kind of just played around with this until I thought it looked cool, and made sure that this hole was big enough to fit an ornament. So from that envelope, which is very simple, now we can do a lot. And so from that, I'm going to walk through how we made what we're calling the orbiting wave ornament, which is, I don't know, a cool name for a cylindrical gyroid. So to walk through how we made the gyroid structure. So the body of this is going to be that envelope of the cylinder. Then again, I'm defining the radius cell size and the height cell size of this by the radius and the height of the ornament. So if I scale this in any direction, it will have the same number of periods. And this is not only important for kind of maintaining the aesthetic, right? So you always have the same faces. But I'm also, because we're actually making these and producing these, I'm sort of in my head kind of self-selecting for geometries that are self-supporting and are basically going to print flat on a build head with no supports, because as fun as it is to make ornaments for a lot of people, I really don't want my team clipping off a million supports for this project. So this is actually, and on our website, we talk about this as basically being a zero waste product. So the product is printed on demand in exactly the shape that you're going to get. There's no support structure that's being thrown out. We're not, making more than people are ordering. So, all right, so we've defined this body by those parameters. Again, it's a gyroid and it's a cylindrical one. And then we're going, sorry, let me show, this is kind of what it looks like originally. This got a little sharp in the middle and I wanted people to be able to see through it. So I'm gonna basically sub out the center to get to this. Very easy. So then I thought, well, here's my hook. And let me just, it's at the top. This isn't quite aligned. So all I did next was to take that gyroid that I made and rotate it around the center by 45 degrees, which is what it needs to now aesthetically line up with where that hook is going to go. And then here's where it gets really fun. We're going to actually generate the orbiting wave using the most important block. This is on the midterm exam, everyone. The most important block in nTopology is the ramp block.
The ramp
Right.
block.
Everybody guessed it. That's amazing. So seriously, if you learn one thing in nTop, you have to learn the ramp block. Figure out how to use it first, and you'll save so much time later. So the hook is at the top of the ornament in terms of Y, right? So we're going to, the field that we care about for the ramp that I'm talking about is Y. So as I go from, and then this is sort of, we're going to decide where we go from and to, but let's just say as I go up in Y, I'm going to basically start outputting one thing at the min and then sort of blend through transitioning, outputting the other one at the max. So below the min, it's fully my out min. Above the max, it's fully my out max. And then in the middle, I'm geometrically blending between those two. And this is a really important trick that I learned from Chase, who's also on the customer support team, which is not taught in the nTop 101, but this is a like a advanced, maybe graduate level nTop usage, but anybody can do it. It's really easy. We're going to actually make the implicit body itself. So basically so let's just show what we're going between. So we're going to go between this and this. And if it's below like 15, which is a third of the radius, so I'm basically saying, somewhere before we get to the end, I want to start the blend. And then right after I get to the edge of this thing, it better be fully the hook, right? So I'm going to blend between these two, and then the output magically looks like this. So you can see if we kind of zoom in a little bit here, and maybe I'll make it slightly more beautiful. So again, we're going in Y, so Y is up on the screen, and it's fully this gyroid ornament that we just generated. And then in that transition, I'm sort of ramping into this hook and cylinder envelope body so that I have the hook and I have enough of a graded area that it's gonna be continuous with my part. Okay, so that is how to use the ramp block in a really fun way, where you have the implicit bodies themselves as the out min and the out max. And now what I'm going to show is once we built that, now we can basically use that over and over and over and over again, right? So I just spent whatever 12 minutes talking through the generation of the first one. Now in, I don't know, we could count in 12 seconds, I'm gonna make 3 more. And so this is really the power of the reusable workflows in nTop. So I just copied, this is exactly the same ramp as the orbiting wave ramp, but now I'm calling it the ornament machine. And so just to really drive this home, I can swap in. So I'm going to look at the ornament machine. It's not yet rendered because I haven't decided what the body is, but I can choose any of these beautiful structures, let me just go back down to medium resolution so that these show up fast. So I dropped in a Schwartz body, bam, I've got a Schwartz ornament. I drop in a diamond body, bam, I got a diamond ornament. I drop in this spiral diamond, bam, I got a spiral diamond. So this is insanely fast, and I'll go into these really quickly, but just to show you that like I'm not hiding anything up my sleeve, I've decided to attempt a dangerous live event here on nTop Live. We really are live. So I'm going to do it live. So I've got this TPMS that I loaded. So that is right here for those who don't know where to find it on the top block. And I'm going to say that, again, the body is this cylindrical envelope. Let's say I want like a 3mm unit size with like, I don't know, a little bit of a negative bias so that it's a little more open. Gyroid. Okay, what's that look like? That looks kind of cool. Wow, we did it live. That's so amazing. And then boom, drag it in and we have this amazing like SpongeBob ornament. Coral themed ornament. So looks a little weird at the top. Maybe you want to like shift that around aesthetically, but actually this one really highlights because of this. So I didn't really pre-plan. Let's just go to a higher res. I think this actually really highlights exactly what's happening in the ramp block, right? So just before the edge of the cylinder, right, I'm starting to transition from a gyroid to this solid hook and cylinder envelope. And so you can see this gyroid starts to get infilled slowly. And that's why it kind of creates this skin on the top. By the time it gets to the end, it's fully a cylinder. So anyways, maybe not exactly the one that I would want on my tree, but I think demonstrates the power of being able to do it live and do it really quickly and reuse these workflows, right? Okay, so that was the workflow for using the ramp block and the TPMS structures and being able to swap them in, on demand. I guess we could go into all these. I don't think it's worth spending too much time on, but I guess the only thing I want to highlight for all of these TPMSs, again, all of the dimensions are relative to the original scalar inputs that we set. So one really fun thing that that is sort of a consequence of that, right, is, so here's how it looks. Here's when we run it through the ornament machine. But now let's say, hey, this is pretty cool, but I want it to be, I don't know, twice as big and twice as thick. Then I shouldn't have done this on high res. It's okay. We'll sing the 12 days of nTopology while it renders. Okay, so I just completely changed the inputs from the beginning to make it twice as big, twice as thick. And again, everything still works. So the hook's still in the right place. This cylindrical diamond lattice still looks super cool. Our design criteria here for this was to maximize joy while minimizing the weight. And I guess we could go into a whole separate top op. Maybe that can be the follow-up to this. We're gonna we'll literally have the cost function be maximal joy, and we'll minimize the weight for a given joy. All right, so that's what I wanted to show for the TPMS styled ornaments. Again, super fun, super powerful, super reusable once you get the whole thing set up once. And this is like why we sort of waded through the boring part of defining scalar variables, is to be able to reuse them again and again and again. Annika, how am I doing on my examination?
Doing great so far.
Okay.
Yeah.
Good.
I think you're
anything
showing off.
anything you want to point out or highlight from that workflow before I go
Yeah,
into
I
the
think,
dangerous territory of beta blocks?
yeah. Well, I think showing off the ramp, definitely a really key component to have when you're playing an nTop. I will say for anyone scared of the ramp from this mini intro, Ray just definitely jumped into the deep end on that ramp block. So there are
Sorry.
definitely simpler ways to go into it. No worries. I think it's good to show off the implicits and how you can actually take advantage of the fact that everything is a field.
Yes.
But there's a lot that you can do with the ramp block to change all kinds of things and really take advantage of our field-based modeling. I think it's cool to see how you can go in and change some of those original inputs. Because this ornament is made completely within nTop, then you really have that power to be completely parametric like that. Oftentimes people bring in parts that are already from CAD and then be able to manipulate it from there. But when everything is implicitly generated, then you have even more power. So cool to
Right.
see that.
Yeah, awesome. And I can't think of a better person to learn the ramp block from than Annika Norden. So
Thank you.
I've learned it from her, and she's got I'm sure there are a million videos at this point live on nTopology.com of you teaching people really from the beginning. So you're right. I apologize for jumping straight into
No, I think it's good to show
this
off the tough stuff,
sneaky.
but we don't want to scare anyone too.
Okay.
We had a good comment come in. Someone just asked if the joy value is inversely proportional to the support volume.
Yes,
And
absolutely.
I think that is completely accurate.
Yes, at least for my team who's actually in the lab printing these, then yes, we do not want to bring joy to our customers at the expense of the joy of our team. So yeah, if we can print without supports, I'm all for it, and that's one of the many things that we're doing with nTop is trying to minimize those support volumes. Okay, so are you ready, Annika, for the beta block of the
Beta
snowflake
blocks.
scaffold? So now I will say this is an important aspect of the ability to go from design to like on Shopify in a few days is we effectively just did our user testing with the actual product itself. So I will not reveal the sales numbers, but I will say that we saved this one because the snowflake scaffold ornament has been dramatically the most popular of the two so far. But who knows, if I had actually done, maybe this diamond one would have won out. You never know. So here we go. So we're going to reveal the secret blueprints behind the extremely popular, highly acclaimed snowflake scaffold ornament. I have seen this ornament in the hands of small, joyful children. I've seen it on a Christmas tree right next to the Daft Punk ornaments, and that was probably the highest compliment that we could have received for this ornament, was that it would be placed in close proximity to Daft Punk. Extremely important. So here I'm going to go through the beta block, which is the periodic lattice body. Which one's that? I forget the structure, whatever that.
It's
What's
that
the icon
first
look like?
one.
This one? Oh yeah, here we go. The first one.
Yeah.
Icon looks a little different. Okay, I'm used to just typing them. So everybody, once you start learning those, you're just going to type them here.
Yeah, the ribbon is
The tip.
helpful when you're learning, but once you get into it, that little search bar is going to be your
Yeah.
best friend.
Exactly. Okay, so we're gonna break down the whole thing one by one. So first off, well, actually, I'm gonna do this last because I think it makes more sense to define the cell map first. So first I need to figure out the map of the cells. And I'm gonna do it again in that same cylinder envelope volume. Again, I've set the radius of the cells. So this is the periodicity of the cell map. Also, it's a cylindrical cell map because it's a cylindrical ornament. The radius is just a third of the radius of the entire envelope. I could play around with that. I could make that a quarter. I want to make it even integer divisor so that it's kind of got an even number of unit cells in the ornament. Same thing, the height is going to be half. And for this, I decided to do you know, 12, um, 12 arc counts, or so the angle is divided by 12. So there's 12 units. But again, we could have made that, I don't know, 6, and it would look like a very different kind of snowflake. So again, all this is fun and aesthetic. So now we're going to, so within that map, so here's the map. Within that map, the unit cell of that map is the very simple and elegant BCC. So that's what, I guess that's what it would look like in Cartesian coordinates, but it's not. And so again, we could have swapped that out for something different. I don't even know what this would look like. Let's just do this for fun so that people could see. Maybe I should do it at a lower resolution. So this would be, if it were FCC, clearly more dense. So now the unit cell, again, you have to think in cylindrical coordinates. It's BCC in a cylindrical basis. Now we're going to do the ramp block again. As we've mentioned, it's the most important block, but we're going to do it in a different way and kind of a fun way. So with this ornament, I thought, oh, well, I could, I don't need to add that extra hook thing. That would look kind of weird. I'm just going to need to make sure that I can hang, I can sort of get in there to hang a hook into one of the, I guess from a vertex, right, of this lattice. And so the way that I wanted to play with this was, now I'm not ramping implicit bodies. Now I'm ramping the thickness of the lattice itself. And so the fun thing, there's lots of ways to do this without beta blocks, but the fun way of doing it with the periodic lattice body beta block is that I can kind of have everything all in one place. So let me explain what my sort of design criteria. So what I want to do, I sort of ruined it and showed the result at the end, but let me explain how we got here, which is in the center, I want it to be thinner, so that I kind of get this fun, you know, high resolution, kind of intricate center, right? So you can see that it's actually getting, the beams of this are, you know, ramping to be thicker and thicker. On the outside, I want it thicker because we do have a guarantee that this is the one ornament that you're not going to have to worry about falling off the Christmas tree. And so I really got to make sure that I've got a thickness where I can be true to that customer promise. This is an incredibly strong ornament. So I want to go from thin to thick from the inside to the out radially. And then I also want to make sure that I've got at least this one strut where I'm going to hang the ornament from, that's thin enough that I don't need to have like a surgeon insert the hook. So here's how we did that. So I'm going to kind of reveal the behind the scenes. So see, all right, so let's take this away for a second. So I've got a cylinder in the middle, which is where I want it to be thin. And I've got a sphere, well, you can barely see that, a really tiny sphere on the top, which is where I want the hook to hang from. And so let me just go to medium res so we're a little faster. So you can see these two are the two places where I want it to be thin. And now what's really fun is, so then I'm gonna add those together. I'm gonna Boolean those together, and then I have a note to myself here that we're going to field view this. So let me just make it look cooler. Where do we go? Contour interval. What did we say? Okay, 1. Great. So this is where the math. This is where nTopology made me wish that I paid more attention in math class, because everything is math in nTopology. Every object is a field. So we're going to actually stop looking at them as bodies and start looking at them as fields. So inside the body is negative. That's a little bit counterintuitive to me when I first learned it, but it makes sense. So basically the surface is 0. right? And then we've got this field that's going away from the body, and that's a positive number, okay? So we've got this middle that I kind of want to keep thin for aesthetic reasons, and then up here I want to thin it out just a little bit to add my hook. So this is now the field that I'm going to modify the thickness of the block by. And actually, let me just make this a little, yeah. Let me just make this a little bit smaller so that I can do a cool trick. So then if I overlay the body on top of that field, right? So you can see now what I'm talking about, which is, so here in the, let's just go through the ramp really quickly. So basically if it's, you know, 0, which means if it's at the edge of those two bodies, right, then it's going to be a millimeter beam thickness. If it's the radius, and again, we could figure out how to scale this, but I just decided that it made sense naturally to like have the maximum be the radius of the part. We could totally play around with how sort of steep, so to speak, we want the curve to be. But at the radius, right, at the edge, I want it to be 3 millimeters, because I know if I've got a 3 millimeter beam on a BCC lattice, like you could take a baseball bat to core alpha and it'll be okay. Or your kids aren't going to break it. Okay, so now what's fun is, so you can see here in this overlay, here's where it's thin, but then we can also check out this. Now all of a sudden starts to make more sense from the top. So we've got that, actually, sorry, it will make more sense if I do it on this one. So on the top where I want to hang that ornament, you can see that the beam thickness is actually getting thinner and thinner, right? So this is where my top is. So that is a very visual way of, again, we're now using the ramp block this time to ramp the thickness of the snowflake and create not only kind of the cool aesthetics of the center that we want, but also the location for us to hang it. And then just to fully show then the full workflow. So that the way we did the cell map, let's close the field view. The way we did the cell map, it's actually bigger than the envelope of the thing, because it's sort of allowing for all the points that touch that. So we trimmed it to create the final ornament. We trim it by intersecting it again with that envelope. And then the final thing was, this is more just like a marker for us on our team to know where that thin part is and to put the hook. And I guess for the customer, if they wanted to change the hook out to know where to put it, I just booleaned on a sphere kind of at that top point. So there's a little nub there that indicates, okay, this is the thin one that we're going to hang the hook from. So that is all of our top secret design details behind the most popular and rugged ornament of the 2020 holiday season, the snowflake scaffold. Annika, anything that I should have highlighted in that, I don't know, that I missed or that you want to point out, or demerits for my midterm examination here?
No, I think that's great. I think showing off another example of that ramp block, I think is valuable. Being able to thicken things based on another field, in this case, based on two implicit bodies. So I think if you show that field view again.
Okay, let's do it one more time.
Wait, that kind of snowman shape that we saw is really due to the fact that you have just two different bodies and two different fields that are just overlapped into one. So then you have these two fields, these distance fields, and when you're overlapping them just by having that Boolean union, then it's joining them together and creating that really cool contour, but then also being able to manipulate the thickness at actually two different locations.
Yeah, and actually maybe we could just, sorry, I didn't name these something cool, but so just to drive home Annika's point, So this is the field of the little baby sphere that I'm using to define the top. And this is the field of that center of the ornament that I decided I want to be thin for aesthetic reasons. And then when we, like, again, this is where I think it's a good example of just like everything is a field, everything is math, right? When we Boolean them together and look at their combined field, now we can operate on that in a different way. And I think this is something I don't know, I will say this is, you really do need to just kind of get into nTop and start playing with it to think differently like this, because this was not, even in designing this ornament, I actually can remember, I had an earlier version where I was kind of trying to solve those two things in a different way. And it was just creating more complexity. And I think I realized, like, oh, wait, what am I trying to do here? I'm trying to just thin the beam. Okay, where am I trying to thin the beam? Okay, just like add those together, add those places together and do it once. Instead of like, I mean, you could solve this a different way with, like, I don't know, a dozen Boolean operations and blend radiuses and what's the
And getting deep into the
like,
math tab as
yeah,
well.
offset body, blah blah blah. But I think
Yeah.
so. I think what I love about, I mean, what I love about this, I think Annika's trying to give me, well, thank you. You gave me like a good opportunity to highlight, is this is kind of like so one, in some ways I'm blessed that I'm terrible at CAD, and I sort of just decided not to learn it, right? Because this is an incredibly like un-CAD way to have designed it, right? Like if you were really used to thinking about faces and thicknesses and all that stuff, you'd probably do it a totally different way with a bunch of Boolean unions and intersects. You'd probably use offset body to, to thin out the part that you wanted from, and so what I love about this is we sort of approached it like you could never approach this design this way in any traditional CAD tool.
Right. And I think the fact that you hate CAD makes you a better nTop user. I think sometimes it's hard for people to learn nTop because they're coming from that traditional CAD
Because
environment.
they're too good.
And
Yeah.
you want to snap to something, or you want to pull this exact face.
Right.
So I think for those that maybe have a little bit of trouble with nTop, it's almost forgetting everything you know about traditional CAD and just diving into the world of fields. And it's really a different way of thinking, which I think for those who haven't spent as much time in CAD or hate it, it puts them at an advantage.
Yeah.
But it's a very different way of thinking that I think is very cool.
Yeah, I love that. And I think it's appropriate, right? I mean, it was just the solstice yesterday. So we have to shift our thinking to be in alignment with the universe. And I think the universe is calling us towards
So is
implicit
this
design.
Saturn and Jupiter, or is this an
I
image of
think
Saturn and
so,
Jupiter
right?
right here? I
I
think so.
forgot to mention that
I saw it in the
deeper.
sky last night.
Yeah, I forgot to mention the deeper uh, galactic meaning behind the design here. So yeah, thanks for reminding me of that one. That was 100% intentional. Yeah, this is the exact radius of Saturn and Jupiter when viewed from, I don't know, Mars. Something like that. Okay. Anything else, Annika, you think we should highlight on the snowflake scaffold before I show? I just want to show at the end. So now we're going to start to make this real, right? So we're going to leave math and fields, and we're going to start to make it real, and we're going to need to get into, at least for now, I'm still using the crutch of STL meshes. I'm working towards freeing my soul of such burdens in the future, and slicing directly in nTop and all kinds of beautiful things that I'm sure we'll talk about in 2021 together. But yeah, anything you want me to kind of touch on there while I've got the more mathy side loaded before we go into meshing?
I don't think so. I think you showed everything off really well to the point that someone has actually asked for this file as a study guide for their midterm. So.
Okay, yeah, I'm happy to do it. We'll find we've got we'll find the right way to share it, but I'll figure it out. I'll work with my team, and yeah, certainly happy to share the joy.
Fun one to check out. So
yes, exactly. Great. Okay, so now let's get down to business. So I wanted to show just how we mesh. I called this the polySpectra Ulti-Mesher 2021. It's not really that special, but you know, meshing, again, I'm not really good at CAD. I sort of avoided ever learning it for a long time and found it kind of frustrating. So this is something where, you know, there's some classic, let's say, rules of thumb, right, for meshing that, like, I'm sure Annika is like a super you know, knowledgeable about. Okay, you know, if the beam is this, you should have the mesh be this. But I think something that's also really important is, like, you just kind of have to play around with it. And it's also one of the, there's a few operations within nTop that are you know, the computation time scales very steeply with the size of the object and the refinement of the mesh. So things like smoothing or meshing can really tank your machine if you're not doing them intentionally. So what I thought was fun is, this is a trick I learned from Jonathan Harris, who is what's application engineer. I forget his exact title. Another nTop amazing person. So he kind of taught me this trick. I really, he had this whole workflow around smoothing lattices, and I was asking him, oh, is it better to smooth the whole thing after it's done, or is it better to smooth a unit cell and then make a custom unit cell, right? And he was like, oh, well, you know, it depends, but hey, here's this cool workflow where you can kind of have a little bit of the best of both worlds. So let's close the field viewer. So I'm just going to show really quick the Jonathan Harris micromesher technique, which is basically just take a little box and like intersection of the thing that you want to mesh, and let's play with that first. So this is super important because I'm running Zoom right now. I have PowerPoint open, KeyShot open. I want to keep the audience engaged and not mesh for like an hour. I would rather not have to sing, you know, the 12 days of nTopology, you know, to count down and watch you or wait, have you wait for me to mesh. So I've got this tiny cross section kind of slice. It doesn't really, you could move it around to make it a certain part of the part. I like this. It's kind of representative of what I care about. And then I'm going to mesh so I've called this micro mesher, which is, again, in this case, we're taking the snowflake scaffold ornament and just have it, I'm just looking at this little tiny box of it. Okay, so now I'm going to go into the polySpectra Ultimesher 2021 highly proprietary meshing techniques here. These parameters have been refined over all of COVID by myself. So basically, I'm starting out with, I guess it doesn't really matter. Let me just show you, right? So this is where we could just kind of say, okay, I'm doing mesh from implicit body. That's another one you're going to need to get to know if you want to bounce these out to other, you know, softwares to arrange them for printing. But let's say I just don't really know what makes sense. You know, I don't even know what feature size means. Like, okay, you can try 1. That looks like a really cool, like, cell shader manga cartoon thing, but not really what I want. I don't know. Let's try a 1/2. Okay, still kind of chunky. Let's try 0.1. Okay, now I don't know if you can notice that, like, little split-second delay. So this is what I'm talking about. This is going to get way more computationally intensive, and even a tiny change like going from 0.1 to 0.15 is going to have a very different runtime once you get to these big blocks. So I'm testing it out on the smaller one. So I can't, you know, I don't know. I guess we could go to a higher res to look at this, but, like, I can't really tell the functional difference between these two. So whatever, we're going to call it 0.1. And then another thing that for a lattice like this, it's not going to save us that much time. But one of the things I really like doing is actually, let's do it on the, let me show it on the, what did we call it? The orbiting wave. Let's do it on the orbiting wave, because so now I'm going to simplify the mesh. So depending on the size of your thing, right, these meshes might be a gigabyte, right? And that's, you could print with that. It's just not that fun to have to move a gigabyte size STL from, you know, my machine at home over the internet to the printers at work. And so sorry, I'm switching this over to the orbiting wave gyroid, cylindrical gyroid one, to show a little bit better what simplify is going to do. So here's the mesh, and actually adaptivity does a little bit of this by sort of adapting the flat faces. But you can see in the areas of curvature, there's a very, very fine grid of voxels that gets the, you know, the triangles of the mesh get bigger as we go to a flat face. And then I'm going to use simplify mesh. And my rule of thumb here is, you know, so my rule of thumb is about like 10 or 20 microns. You know, the printers I'm printing on are maybe 50 to 75 micron pixels. So as nice as it is to kind of like look at a much higher resolution mesh like on my computer, like it's just not, you know, yes, there's anti-aliasing and you know, built into the scripts, right? But you're really not, you know, the physical object isn't going to be any finer than, I mean, the highest resolution printer we have is maybe 25 or 30 micron pixel, right? So what I'm going to do is basically say, okay, I'm going to throw out all of the, or combine all of the triangles that are kind of under that threshold, and we could see, you know, what this does at different amounts. So like if we made it 0.1, again, now we're getting back to a chunky, like kind of low poly mesh. So this is 100 microns, this is 10 microns, and this looks pretty good. And now what I don't want to go into, but is important for the practicality of this, is like the file sizes of these two things are going to be very different, right? So there's 158,000 faces in this one, and there's only 33,000 faces in this one, right? So you know, whatever, header aside, right? This is like a five times reduction in the file size of these two things. So that is the polySpectra Ultimesher 2021 edition. And then we'll give it a file name and export it out. Annika, anything we're now going to go well through the virtual reality and then into the real reality of actually making these real. Anything you want to highlight before I leave nTopology?
I don't think so. I think that last little trick is a great one, because oftentimes that getting that right feature size, but then getting a proper or an okay processing time, it's just a big compromise, right? So getting that little block first to test it out to see, okay, this does make sense. Now let me have my computer run that for a little bit of time, and I'll go get a coffee in the meantime. But
Right, right.
it's a good tip.
Yeah. And one of the things actually I've done in the past, so here we were, one of the things I've done in other projects that I'm sure will pop up on our amazing list of 2021 joint webinars together. But so in this case, I didn't really have something like the beam thickness of the lattice as like a predefined variable, right? But one of the things that I've done in the past, especially when working with lattices, is I can say, you know, actually, I want the feature size of the original mesh to be, so whatever, like, let's say this was like the beam radius, or well, whatever, let's call it the torus. I want it to be, you know, a 12th of the torus radius, or, you know, a 20th. And then that's really useful when you have, let's say something that is the lattice. Well, one, you want to tie the resolution to the lattice dimensionality, right? Because you want to accurately represent the lattice. But then maybe the part itself is going to scale for some different, oh, it's going to be this big for this use case, this big for this use case. And you don't want to have to, so you can kind of create like a, and it can be useful in terms of keeping the file sizes of those meshes more or less consistent, right? So if the if the resolution of the meshing is tied to some physical parameter that scales with the size of the part, it's another way to keep things consistent. And
Exactly.
I've had some things I've designed where every mesh is almost exactly the same file size, no matter how big the part is, because that's how I was kind of choosing to scale things. So that's another trick that we could do. Okay, amazing. So now we're going to move out of nTopology and into, well, first I just thought it'd be really fun to show a fake world. So now that once you have that mesh, what are you going to do with it? Well, a really fun thing you could do is pretend it's somewhere. So I wanted to just spend 2 seconds showing off. I pretend I have a giant lattice on this snow-covered road in Keyshot. So you could play around with rendering it in your favorite tool. This, you could argue how good my fake Core Alpha looks like the the real Core Alpha. But then I wanted to now show how we made it real. And for those of you who are new to polySpectra, our motto is make it real. That's kind of like our just do it. Oops, hold on. If I share this now, it will reveal the last slide. I need to, give me 1 second. Okay. So how did we make it real? All right, so again, I'm just going to show a few different images of kind of the print process because I think it's fun. And Annika said, hey, it's really fun. We spend all this time doing webinars inside nTop. Just show them how it got out of nTop. So one of the things that was important, again, we literally thought of this like a couple weeks ago as like a fun thing to try, and we had joked about doing ornaments in years past, and it was just like, oh hey, like let's actually do it this year. So one, it was very fast to design in nTop, and to design to be able to print self-supporting with no support structures. But we also kind of kept the ornaments relatively small, because we knew that we'd have insane demand for these ornaments, and we wanted to give them away to a lot of our friends as well. So we designed to be able to print 12 at once on our biggest printer, which is an Asiga Pro 4K. And so you can see all of these printed side by side in an array. Here is the orbiting wave ornament, again, another 12, and then you can kind of see from the side. So these are coming out, just after printer, getting a little bit clean. And then we were able to immediately go into testing. Well, we had to make sure that the hook fit on there. So check. And then we got to make sure it hangs from a tree. So you can tell the design criteria are maybe less rigorous than other, maybe some of the aerospace applications that some of the folks on the line are thinking about. But it does in fact hang from the tree. It's lightweight enough to not weigh it down too much. The hook fit in the right place. I will admit that my very first design of, here's like I'll give away like an earlier prototype, did not fit the hook. So we had, on this one, we had one iteration. On the orbiting wave, we managed to nail it on the first try. Packaging, gonna put it in a, some nice wrapping paper, nice box, and then voila, on-demand additive manufacturing of a consumer product in a matter of a few days. So I think I can honestly say that it took me longer to set up our Shopify store than it did for me to design the part inside nTop. So I like Shopify. I'm not dissing them, but I think I'm just trying to highlight the ease of the design here. And so then let me show you. We had a minor snafu. We were supposed to get Annika her very own in time for the webinar, so that we have both of us with these in real life on the webinar. But the USPS is quite overwhelmed right now, so I'm going to zoom in. Let's do them in order. So I'll do the orbiting wave first, and let me just, I need to be able to see myself to zoom this thing in. How's that? Is that kind of in focus?
If you stop sharing your screen, then we'll be able to see a little
Oh,
bit
that's a
clearer
good
too.
idea. Thank you. All right, so go to shop.polyspectra.com to see for yourself, but here it is in real life in my camera. So you can see the, the layer lines of the print. We printed them pretty thick to do them fast, but it's kind of cool. I think it kind of adds.
Yeah, I like the effect.
It kind of adds to the aesthetic of like this sort of the topology, so to speak. And then we've got the snowflake scaffold, this year's most popular ornament. And again, you can see like the kind of vibe here I was going for is like somewhat naturally inspired, but also like very clearly for engineering. And so yeah, somewhat natural, and yet at the same time intentionally engineered. So you can see kind of the layer lines have a cool effect on that one as well. So we did it. Did I pass my midterm exam?
With flying colors. Nice
Wow,
work.
it's amazing. It's amazing. Yeah, so I guess just to recap, it kind of a fun way to show off some of the different tools in nTop, two totally different uses of the ramp block, one to define the beam thickness here and really think about fields in the beginning, and then one to kind of have this reusable workflow where regardless of my TPMS body, I've always got my hook place to hang from. And again, what everything about this was fast, and I think even Annika and I were on our last customer success call of the year, and we were just like, hey, wouldn't this be fun? Like, let's talk about this, let's do it. And like I said, I think I spent more time cleaning up the file to make it presentable than I did designing. And I really am, it was fun and playful and seasonally appropriate, but I think if anything, I'm like walking into 2021 with like really a new uh I want to say like confidence of just like, whoa, with this, like this synergy of implicit design and production additive manufacturing is really powerful, and like this is going to completely change the speed at which you can design and deploy new products. And I'm like kind of excited to have all the meetings go away and get really nerdy with nTop while it's kind of cold and quiet a little bit here. And I just think that this is, I mean, I think both from us, like, well, and for so many startups, right, like time is money, right? And so maybe for folks that are on product design cycles that are 5 to 10 years out, this is more of a nice to have. But I think for people who are thinking more entrepreneurially and really want to iterate and actually like get feed, so we just put them online, we put them for sale. And again, I don't want to diss the orbiting wave, but like snowflake scaffold has been crushing it in terms of the sales. And I think the other thing about that is we're not sitting on some huge inventory of orbiting wave hoping that our like focus group it was, you know, accurate representation of the market. It's like, hey, we designed this thing, it's fun, we put it online. If people like it and buy it, we make more. If they don't like it, then we've got the whatever, the couple that we used to make sure that it worked, you know,
Hmm.
to put on the Christmas tree at work.
Yeah.
And
Yeah, no, and I think it's really cool in the fact that how short that entire timeline is from actually creating it within nTop to selling it online and having customers put it on their Christmas tree. Maybe it has to do with the minimal testing, but usually when someone's creating something in nTop, it does take a little bit more time to actually get it into market, but that also has to do with the timelines of corporations and things like that. So I think this is a really cool example where you're able to come up with something really fun, and produce it. And that's the power of bringing nTop together with something like polySpectra as well.
yeah,
So I mean, for me, it's extremely cool to see because the customers that I work with, sometimes we're just spending time in the software, which makes sense, right? That's what I'm there to help with. So, and then beyond that, I don't see what happens afterwards. So actually being able to see things in the real world and hoping my ornaments get delivered soon to actually hold an nTop piece in my hand, I think is really incredible. So
yeah.
thank you.
And actually, I think that's kind of a funny time point comparison is like, we shipped you that more than a week ago. So
Yeah,
the time it took for the ornament, and you know, I guess we thought we had plenty of time, so we didn't like rush mail it, right? But the time that it took the USPS to get you your ornament
exactly.
was basically longer than our entire product design cycle, which is kind of an amazing, you know, amazing analogy, for just thinking about, you know, this, the true speed of this whole thing, right?
Hmm. Definitely.
Man, that's so funny. So I think we've got a couple more. Oh, we've got a great webinar. Thank you. Comment. All right. Thank you, Doga. That is very kind of you. If there's any other questions from the live audience, I think Annika and I would be happy to hang out for a couple more minutes and answer them. And um, if we don't see any soon, then I don't know, I could sort of dangle ornaments and dance, and we could sing holiday songs, if we want. But yeah, um, the one thing that I'm curious about, maybe, and this can be kind of a, we didn't show any of the like FEA stuff, but just thinking about that testing, I guess, without us going back into nTop, Annika, do you want to just talk super quickly about, okay, let's say now I'm a real engineer and I know that this thing's got to like hold some load, or like I know that this thing has got to be, I've, you know, this is like the dinosaur that the SpaceX astronauts snuck on the capsule that threw off the center of mass, the whole thing, right? Like I know my mass budget, or I know my load condition. Do you want to just talk at all about, and this is a side of nTop I'm still learning a lot about, just the ability to then ask that question in nTop without ever leaving? So maybe I'll ask you that, and in the meantime, if people have questions, put them in the Q&A, now or never. Happy solstice. But yeah, Annika, let's talk about
Yeah, so
like,
we do have some finite element analysis solvers within nTop. So if we're thinking about maybe testing that the orbiting wave, right? It's just a matter of grabbing onto those specific bodies. Maybe we're marking the torus as the rigid part, and then adding the gravity force on the whole body. Otherwise, and then just using that same block system. So it's not going to be exactly the same as your typical FEA solver because you're building it up a little bit differently. But the nice thing is that once you build it up, then it's the same exact way as when you use that ramp block. You just swap out any of the bodies and you can run it from there. So then you can get like a nice stress analysis. Maybe we then iterate with that stress analysis and say, okay, where we have really high stress, let's maybe thicken that wall a little bit more. So you've got a little bit more structure there. And
Oh
then where
yeah,
we
so
have
we
no
could top up.
stress.
So we could. I'm just gonna like mime what she's talking about, but like, let's say like I know the weight of the child who is going to try to pull this thing off the tree, and I know the thickness of that, um, you know, the like the body right
Mhm.
there, and I know the ultimate tensile strength of core alpha. Now let's go solve for that, and I can do that and make sure that this thing will meet my design criteria without ever leaving nTop.
Exactly. Yeah. And since you already have that information and since you're running it within nTop, maybe you see that stress is too high over here. So let's take that exact section where the stress is too high and let's thicken it. And then maybe that will help. And it's not going to snap when little kid goes hanging from grabs onto the ornament and tries to hang from it.
Awesome. Well, that's amazing. I like that as a toy example, and we can make episode 2,
Perfect.
the top up version of that. So anyways, with that, Annika, thank you so much for joining me here and for grading my midterm examination. I
Yep.
think
Thanks for
I'm gonna
having
need,
me.
yeah, I think I'm gonna need to learn the FEA side and the top up side
That's
to go
semester
into
2.
my
So,
final examination.
yeah,
Um, a-
exactly.
anything final that you'd like to share with audience before we jump? I guess people can find more about nTopology at nTopology.com. We'll include all those links in the comments for this.
Mhm.
Obviously, the ornaments are at shop.polyspectra.com. Is there, yeah, anywhere where you want people to kind of reach out to you or find you?
Yeah, I mean, you can reach out to me definitely on LinkedIn, or
Okay.
I'm at Annika Norden at nTopology.com if you have specific questions. But definitely check out our website. This is one of many, many nTop lives. So there's a lot of other great workflows that some people internally and some of our customers are showing off as well. So definitely worth exploring those. For those interested in nTopology, definitely check it out, and maybe we'll be working together in 2021. So.
Awesome. That's amazing. Well, I think this has been an extremely fruitful collaboration, and thank
Mhm.
you so much for your hard work this year of making me a very successful customer. I'm very grateful, and this was a lot of fun. So
Yeah,
thanks for
well, it's
taking
been
the
fun
time.
working with you, and congratulations on passing.
Yeah.
And we'll have some fun lined up for next year.
Okay. Sounds good. All right. Well, thank you. Bye, everybody.